And this is kind of the beauty of it. All these different data sets are slightly different, and you'll be able to draw conclusions based on your specific graphs. What you see is going to happen with the relationship between the nanograms added versus the transformation efficiency. Let's see. So before we can even calculate transformation efficiency, we need to figure out how many nanograms of DNA is in each of these different sets. And so for this, like I mentioned earlier, just assume that the concentration of pGlow is 2 nanograms per microliter. And we use the formula that was up on the board. Maybe you can see in my tiny window. It's just the microliters of DNA added times the concentration. So yeah, you want to be careful. So you see this number is the microliters of DNA that was added. So we're going to convert it to nanograms first. So 0 is easy. It's just going to be 0 times 2. Here, 3 microliters was added. And again, this will vary a little bit. Some are like there might be like 2, 4, and 8. This one 3, 5, and 7. That's fine. These numbers might be a little bit different for you guys. But the way you solve it, it's still the same. So for this one, it'll be 3 times 2. So 6. Then we have 5 microliters added. So 5 microliters times 2 nanograms per microliter is 10. Whoops, I put 101 for that. I'll fix it. Bam. And then finally, for this last set, 7 microliters was added. So it's 7 microliters times 2 nanograms per microliter of DNA for 14 nanograms of DNA total. Let's put that in there. So now we have everything we need to do the transformation efficiency. So I'm just going to type it out an example first, and then I'll show you how you can have the sheet kind of do it for you. So 0 is going to be really easy. So I'm going to put transformation efficiency here. If you have 0 colonies, if you added no DNA, you wouldn't expect to have any transformants, right? There's nothing to transform the bacteria with. So for this one, it's all going to be 0. Easy peasy. And now, actually getting into this part where we actually have some colony counts. And again, some of them you might see. I'm just going to change these to numbers because it makes it a little easier than having the words in there too. So don't be disheartened if some of them are 0. For this example, a lot of the plates didn't have any colonies on them, but this one had 1, so we can work with that. So first I'll write it out. So we have our colony. We had 1 colony divided by, and for this set, it's 6 nanograms of DNA. We calculated that beforehand. Times total volume. And I'm just going to use the one from the worksheet. So I'm going to use 625 as my total volume and 125 as the plated volume. And you guys can do that too. Just to make things easy. Make life simple. Now, an easy way to do this, if you're not super familiar with Excel or Google Sheets, you can do this. So you can click on a box and put an equal sign. And then what you can do, one option is that you can type your formula right in there. So 1 colony divided by 6 times 625 divided by 125. And again, if you want to be super picky, you could add the volume of the DNA, but here I'm leaving it out because it's such a small amount, it's not going to make a big difference. I'm just going to do that. And then if I hit enter, it does the calculation for me. So if you want to use a calculator, that's fine. Or you can put an equal sign and type it all out. Another thing you can do that's kind of super useful, if you're not familiar with Excel, maybe this is old news for you guys. You can select the cell. So over here I have 1. And then I could select the cell that has my column with the DNA amount. So you can see it says C10 and F10, but that's just the name of the column. But what it's going to do is it's going to take the values in those positions. Hopefully I did this right, and I should get the same number. And kind of like the really nice thing of doing that is that this little corner appears on this little box. You can drag it down. Like these numbers are 0, so I don't know. Let me put some numbers in there so you can actually see it. So you can see it changed automatically, but what it does is it drags that formula kind of down for you, and it'll calculate it based on the numbers in the next box down. So here it's like 2 and 6. But again, if you're not comfortable with that, go ahead and just calculate it out like this, using whatever you're comfortable with. So we're just going to keep going and do that for all of them. And again, for the LB plate, make this a little longer. Stretch them out. There we go. For the LB, here it's called LB minus M, so this is the LB only plate. You're not going to have a transformation efficiency, so let's just put too many to count, or you can put NA, not available. So we're just going to do the transformation efficiency for the rest of them. So I'm just going to do the same thing. Here, I'll just show it again. We want number of colonies divided by the amount of DNA. I have 625 divided by 125. Yeah. I'm going to do the quick and easy thing and pull it down. And nice. Now I have the transformation efficiency already calculated out. Do that down here. Something like that. Here, I'll just do it again. Good for ref. Oh, see. It only works if you have values. So here, it didn't work because there are letters here. So it says 5 colonies. So it's like, how the heck am I supposed to do math with letters? So I'll just change this. Hopefully it'll work. So I'm just getting rid of the letters in there. There we go. Super. So I'm just copying and pasting the formula we put here into here. And that gives us our transformation efficiency. But again, you can always just go through and calculate them out on paper or whatever way you're comfortable with. But now we can see that we have our transformation efficiency for all these different types of plates with all these different amounts of DNA. I don't know, should we just do the average, or should we have them make one for each plate type too?
You mean the scatter plot?
Yeah.
Actually, it'd be nice to do a box and whisker, but probably average.
Yeah, that sounds. I like
That's the easiest. Yeah. Box and whisker would be cool. We'll talk about that another time.
Okay.
Scatter plot's fine. Yeah, do the average of the plates.
Alright, nice. So I was just asking Dr. Burnett whether we should do a scatter plot for each type of plate or just do the average. And we're just going to do the average.
You might do it as a separate table so it'll be easy to graph.
Ah, that's true. Yeah. So
all these numbers, you just do it as a new table.
I see. So sometimes it helps to like rearrange your data. And if we really wanted to do each type individually, it would be super helpful. It makes it a lot easier to arrange your data like this.
Oh, right, because it's spread across.
Yeah, maybe there's a super savvy way to do it, like spread across like this, but I find it, yeah, just put it in their nice little columns. Average transformation efficiency. I'll put the units too in brackets. Make this look a little more professional. Units in brackets. So we have the following types, or the following amounts of DNA were used: 0, 6, 10, and 14. Yes. So we'll do that. So 0, 6, 10, and 14. So I'm just rearranging the data in a way that's a little more digestible. And now we're just going to take average the transformation efficiency for each amount to get the average transformation efficiency for 0, 6, 10, and 14 nanograms of DNA. So 0 is really easy, like 0 for all of them, so the average is 0. Now what we mean by average, so exclude, again, you can't calculate transformation efficiency just for the LB alone plate, so exclude that one. So the average is just taking the we'll add up the transformation efficiency for each one. So here it'll be, for 6 nanograms, it'll just be 0.83 plus 1.6 plus 0 plus 0, divided by the total number of like conditions you're looking at. We have 4 different conditions, so it'll be divided by 4. Well, it's mad because I put it there. So I'll type out what that looks like. For the less math inclined, I'm definitely one of those people. 3 plus 1.66, we'll put 1.67. And then the other 2 are just 0, but I'll put them in anyway, just like as a place marker. And then divided by the total number of conditions, so we had 4 types of plates, ampicillin alone, and then the 3 different sugars. And that's how you would find the average. Now, again, there's also a super savvy way to do it in Excel and Google Sheets, where you can type in an equal sign, and then type out average, put a little bracket, and then you can select the data you want to take an average of. So I want the average of this one. So you can see I highlighted those boxes just by dragging and dropping, and you hit enter, and it'll find the average for you. But you can also do it, just calculate it out, whatever way makes sense for you. This way happens to be a little bit faster. So again, equals, average, little bracket. This is for the 10, yes. Bam. And then finally, this one, average. I think the other word for it that people might be familiar with is the mean. So we're taking the mean transformation efficiency. That's another way to say it. So there we go. We have the average for each condition. 0, 6, 10, 14. Average them. Awesome. Now it might be a little different in Excel, but to do this on Google Sheets, I love it. It's super easy. You just highlight your data, so literally drag and drop. I like to include the headings, so if you have little headings like I have here, you can highlight those. It's super smart. It'll include those as like your axis labels. And then what you're gonna do, so if you can see my cursor here, you want to go up to this toolbar. If your thing's super scrunched, it might not be there, so just like make your window bigger. But you want to look for a little button that looks like a square with these little lines in it, and it says Insert Chart when you hover over it. And I think there's a sheet on iLearn that also has these directions if you need to ever refer back to them. Well, let's go ahead and see what happens. Hopefully it works. Ooh, beautiful. Yeah, and here we go. Like, I love it. It even does like kind of the right chart. Yeah, this is the type of chart we want. You can see the label's already correct. So you can see it labels the axis.
See if on the side there where it says, yeah, see if it line chart, if you can drop down and select scatter.
Ah.
There, that's basically scatter plot. Yeah, there it is, scatter chart.
I see. Yeah, so this is technically the scatter chart where it shows each individual data point. Similar to the line one. The line one's the same thing with the line drawn points. So the way I did that is like this little chart editor thing pops up. And there's a couple different types here. You can see the line that it started out as, and you just want to change it to this one, the scatter chart. And bam! And then it's super easy to copy and paste this. You select your chart, Command or Control C. Don't forget, I don't know, I like to put it in here. But then, I think you should also, oh yeah, put a link to your spreadsheet here. So some caveats about that. So what it means is you want to share this spreadsheet with me on your worksheet so I can check your work. Or like I can see that you did it. You don't have to type, I guess do it like this, that's fine. You don't have to like type out each one or like write out each one. If I can see that you did something like this, I know you did your work. So you want to go to the share button. I'm going to go through this because some people they'll put the link, but you want to make sure that's shared with me. So you can just, so here you see get link, only people added can open this. So I would change it to anyone with the link. Sometimes there's an option that says anyone with our mail can open it. And then you can click copy link. And then you can put that into here. And then I can click on this link and I can look at your spreadsheet. You want to make sure, you also want to make sure it's not restricted. Unless like you add my email to it so I can actually open it. So I think just anyone's fine. And then if you're in your R mail account, it'll say anyone with R mail. That's fine too. It's like great on iLearn, and I use my R mail account for that. So anyone or anyone with R mail. Don't forget to change that. Or else I'll be like, oh, I can't see your spreadsheet. Can you please change the settings? And we'll both be super annoyed. So yeah, just make sure to change the share settings so I can see it.